Okay, in this video, we're going to talk more about radicals, okay, roots and radicals and properties of them, okay? How to simplify them and how to evaluate them. So the first rule we're going to talk about is called the product rule. Okay, generically presented, if I have some radical A times some radical B, I can simply combine that A times B under a single radical, my choice. They're equivalent to one another. Sometimes it'll be beneficial to go one way, sometimes it'll be beneficial to go the other way. Okay, so I can think of it as going in this direction also. Okay, depending on the situation, we might want to do that. Okay, so radical 2 times radical 5 is, radical 10. Now, radical 10 is some decimal, right? I mean, generally speaking, we want to leave things in simplified radical form, but radical 10 is some number. We can figure out what it is. 3.16, blah, 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 some number that probably goes forever, okay? So we could approximate it easy enough. Okay, but right now we're just applying this rule. So if I have some X, Y, Z's in there, same old story. I'm gonna multiply those two coefficients. I'll get a 77, X, Y, all under the radical. Sometimes you might get a professor that kind of pulls the radical down at the end there. That's just to say, hey, that's the end of my radical, okay, just to avoid confusion about what's inside the radical and what's not, okay? Now, what if I have this, radical 7 times itself? And I know I just didn't do those little things with the 7s. I try to do that. What about some radical times itself? Well, same idea. It'll be a radical 49, but of course, radical 49, we know it's just good old 7. So a radical 7 or a radical anything times itself is just going to eliminate the radical sign, and we'll just have a 7 there. Okay. Another way to think of that, what is something times itself? Well, what does that mean? Well, that means I've got something squared, right? And a square and a square root, I like to use the word annihilate just because it sounds cool. Annihilate each other. Boom, they're gone. And all you have left is the 7. Okay. What about good old fractions? No problem. It's supposed to be a 2/5 times a 3/7. Well, I'm just going to multiply across the top and get a 6. I'm going to multiply across the bottom and get a 35. And just like that, that's how we could use this product rule even with a fraction. Okay, no big deal. Okay, all good there. All right. So we want to use this idea now because we always want to simplify our radicals, okay? Now, what does that mean? Well, if I asked you to figure out what is radical 20, okay? Now, radical 20 is not a nice, pretty number, and I don't want the goofy decimal, okay? I mean, you could say radical 20 is 4.47, blah, blah, blah. I don't want that. I want a nice, pretty answer, okay? Now, what a simplified answer. So I want to think, okay, that 20, I can use the product rule and say, hey, that 20 is really 4 times 5 because 4 times 5 is 20. And then the product rule says I can call that radical 4 times radical 5. And radical 4, I know, because that's a nice, pretty 2. So my simplified answer is going to be 2 times the square root of 5, or 2 radical 5. Okay, so I've taken that 20, which is unsimplified. It's kind of analogous to an unreduced fraction, and I've, quote unquote, reduced it. Okay, same value, different appearance, simplified form. That's all. Okay, so that's what we always want to do here as we have any radical left in our answer. How about radical 500? Well, it's radical 100 times 5. Which is radical 100 times radical 5, and radical 100 is just a good old 10. 10 radical 5. Okay? You have to be able to spot the perfect square roots, though, the perfect radicals. If I ask you radical 80, you might say, well, 10 times 8 is 80, so I'll do that. Okay, now you haven't made a mistake, but neither one of these is a nice, pretty radical. Okay, so we want to put the brakes on and try something different. What instead of factoring it that way, I said, aha, 16 times 5 is 80, right? And now, what is that going to do for me? Now I've got radical 16 times radical 5, and that's going to be 4 radical 5. And I don't know why all these examples are ending up with radical 5. That's just dumb luck. Okay, so you have to factor it in such a way that we get a perfect square root in there. And so you have to know them, you know, and everybody knows the first handful of them, okay? But 10 and 8, that would be no good. Neither one of those is going to be a nice square root. Now, if somebody asks you to do this, simplify radical 38, you're going to bust your brain here and say, well, what can I do with a 38? Just a 19 times 2, that's all I can do. And neither one of those is a perfect square root, so I can't simplify it. That's as good as I can get. All right. Very good. All right. So I think we're probably pretty good on those, right? We could do a few more, I guess. Radical 12. Spot those perfect square roots. 4 times 3 is 12. Okay. To me, right in this step, I jump. I don't write the next step. I see right here, hey, square root of 4 is 2. 2 comes out. Radical 3 stays in. Yeah, kind of eliminate that one step. What about a radical 60? And again, the obvious factor would be 10 times 6, right? Or 20 times 3, but neither one of those is going to do me any good, right? What might work here? 4 times 15, right? 4 times 15 is 60. 4 square roots out into a 2, 15 stays behind. All right. Sweet. All right, I'm skipping some of my notes here on higher roots because I know those don't really show up on the exam, and I know you would love to learn all that stuff anyway, but if it's not on the exam, we can't really do it in this course. All right, some other properties of radicals. You know, what in the world of algebra, when we're simplifying expressions, we had this little phrase called combine like terms. Remember that? For simplifying expressions, combine like terms. We'll do more of that in the course also. Well, now we're going to combine like radicals. Okay, like radicals. So in other words, if I want to add 2 radicals together, they have to match. And then I'm just going to add the number in front. So for example, 5 radical 2 plus 3 radical 2. Okay, they have to be matching radical 2s. And then I just add the coefficients. It's like saying 5 apples plus 3 apples is going to give me 8 apples. Okay, 8 radical 2. I have to have that matching radical or I can't add them together. Okay. How about radical 5x minus 7 radical 5x? Well, they're both radical 5x. Of course, if there's nothing in front, it's like having a good old 1 there. So it's 1 minus 7 will be a negative 6 radical 5x. Okay, all good there. What about this one? 7 radical 3 plus radical 12. Now, at first glance, we would say, oh, those aren't like radicals. I can't add them together. Not so fast. That radical 12 is not simplified, is it? 4 times 3 is 12, right? And we know that 4 can be extracted out of there in the form of a square root, so it's going to be a 2 out front. So 7 radical 3 plus 2 radical 3, they actually were like radicals, weren't they? That's going to be 9 radical 3. So we always got to watch out for that. If you don't have a simplified expression, you might have like radicals and not even realize it, okay? How about this next one here? We have 4 radical 50x. Might as well throw an x in there to clunk it up a little bit. Minus 6 radical 32x. Okay, now again, at first glance, nothing I can do. Well, let's see. That 50 is really 25 times 2, so I'll say 25 times 2x there. And here I'll say 16 times 2x. So you can see I'm going to have some perfect square roots I can extract out of there. Okay, so maybe I better show a couple steps here. That's really 4 times radical 25 times radical 2x minus 6 times radical 16 times radical 2x. That radical 25 is just a 5, right? So it's 4 times 5 radical 2x minus 6 times 4 radical 2x. So that's 20 radical 2x minus 24 radical 2x. So altogether, we're going to have a negative 4 radical 2x. Okay, everybody cool with that one? I hope. Other properties also apply now with radicals, like the distributive property. Radical 3 parentheses, radical 7 plus radical 5. We distribute that radical across just like anything else. Radical 3 times radical 7 is going to be radical 21. Now, remember, I don't need like radicals to multiply. I do to add and subtract. Radical 3 times radical 5 is going to be radical 15. Okay? I can't combine the radical 21 and the radical 15 unless they are secretly like radicals. So if you think about it for a second here, they're not. Okay, so I can't go any further with that. Otherwise, my attempt would be to try to combine them further. Okay, so that was the distributive property. Okay, we're also going to have more stuff that we've done before. But we're also going to do something now that we haven't quite done before. Okay, you've probably done it at some point in your life, but if we have what's called a binomial times a binomial, and we'll do more of this without the radicals, but I'm just kind of throwing it in now because we're in the radical section. A binomial times a binomial, it's kind of like a distributing process, but I have to do it twice. I'm going to take the 3 and distribute it across, and then I'm going to take the radical 2 and distribute it across. Okay. You might remember the acronym FOIL when you did this maybe at some point in your life. First, outside, inside, last. We can use that, that's fine, but it's basically distribute 3 across and then distribute the radical 2 across. So 3 times 5 is 15, plus 3 times radical 2 is 3 radical 2, plus 5 times radical 2 is 5 radical 2, plus radical 2 times radical 2, which is going to be radical 4. Okay, now we can simplify a little bit. That 15, here I've got like radicals, so I'll put those 2 together and I'll get 8 radical 2. And of course, the square root of 4 is just a good old 2. So 17 plus 8 radical 2 is my simplified answer there. Okay, the old FOIL process, just a binomial times a binomial. Let's try one more of them. 5 plus radical 7 times 6 minus 3 radical 7. Okay, distribute the 5 across. 6 times 5 is 30. 5 times negative 3 radical 7 is going to be minus 15 radical 7. Radical 7 times 6 is going to be plus 6 radical 7. Radical 7 times negative 3 radical 7 will be negative 3 radical 49. Okay, and I think we know what's going to happen there. So in the middle, I can combine a negative 15 and a positive 6. That gives me a negative 9 radical 7. Down here on the end now, this is really 3 times 7, right? Because square root of 49 is 7. So that's just going to be a 21. So 30 minus 21 will be 7 minus 9 radical 7. Okay, oops, 9, right? 30 minus 21, that's not a 9. That's not a 7. 9 minus 9 radical 7. Now that's good enough for me. Now, somebody might say, well, you could factor the 9 out. Remember factoring? You could extract that 9 out of there and you could call it 1 minus, 1 radical 7. And you don't have to show that second one if you don't want to. So you could really do it like this. I would say any of these are acceptable. They're all equivalent. Okay, but this one is probably probably the way to go. Okay. All right. Don't know that it matters for this course, but every once in a while, you'll see the word conjugate. Okay, what that's saying is you got a pair of binomials, you got some A plus B, but then you also have A minus B. Now, I make a big deal about this in my intermediate algebra courses that yes, it's a FOIL process and you can expand it out. And what you get is kind of a simplified answer of A squared minus B squared. Okay, now why is that? Let's just do it. A times A is A squared. A times minus B is minus AB. Okay, B times A is the same as A times B, so I'm just going to write the A first. So plus AB. And then B times negative B is minus B squared. Well, you see when I simplify, those middle terms drop away. Okay, when we do factoring, when we start here, we have to sometimes produce these two pieces. That's a little more difficult. And we'll always look out for this. This kind of has a name called the difference of two squares. I always forget if it's 1R or 2R, so I kind of scribble so you don't know what I wrote. Difference of two squares, okay? Take that and create those two. You kind of have to spot the pattern, but we're going what I call in the forward direction here tonight, okay, with this video. So it's just a FOIL process. Take the first number, distribute it across, take the second number, distribute it across, but it's going to simplify nicely because things are going to cancel because they are what we call conjugates, the same numbers, but one's got a plus and one's got a minus. All right, so for example, 2 plus radical 7 times 2 minus radical 7. Okay, now there is like a shortcut. I could jump right to this A squared minus B squared. Okay, I like to just do it, just FOIL it out anyway. 2 times 2 is 4, minus 2 radical 7, plus 2 radical 7, and then minus radical 49. Okay, so that's 4. These two cancel each other out. Minus, that'll be a 7, so negative 3. Okay, all good? Okay. I think that's all I'm going to do here with this. So let me pause this, stop this video, and we'll continue somewhere else.